Hi friends and welcome. In lesson 4 of this course, we discussed strings along with related topics. In this lesson, we will focus on another vital data type in Python known as numbers. Average software engineers generally need a basic level of mathematics to be successful, so there is no need to be scared. The required level of mathematics may vary depending on the type of application they are working on. Python supports three numeric data types to represent numbers. Integers are positive and negative whole numbers. 0 is inclusive. Floating point numbers refer to numbers having decimal places. Complex numbers have real and imaginary parts. Integers are positive or negative whole numbers of any length with no decimal point. 0 is also an integer. Let's declare some variables with integer values. X equals 100. Z equals 10. The name for the integer data type is int. We can use the type function to know the type of an object. Point. Let's run the program. This shows that all the variables we have declared are all integers. We have the type to be int, which refers to integer. You can use an underscore to group digits. This is particularly useful when dealing with long numbers to improve readability. To improve the readability, we can put underscore. Take note that Python does not allow using comma as a delimiter. Print x. Great. Floating point number is a number with a decimal place. The name of a floating point data type is float. Let's declare variables with float values. A equals. We can make use of the type function to check the type of the variables. Point. Let's run the program. The type shows the type of the variables is float. Python uses E notation to display large floating point numbers. Let's say we have a variable x equals a large sum of floating point number. Point. E notation is short for exponential notation. This is how programming languages and calculators display large numbers. This is the same as 1 times 10 raised to the power of 28. A complex number has a real part and an imaginary part. Let's declare a variable complex number equals. To create a complex number in Python, you write the real part followed by a plus sign. Then specify the imaginary part with the letter J at the end. Let's print it out. Point complex number. Great. Complex number has the real and image properties. To get the real and the imaginary part, it also has the conjugate method that returns the conjugate of the number. Point complex number dot real. Point complex number image. Point complex number dot conjugate. Let's run the program. Complex number.real returns the real part in float format as well as the image property. The conjugate method returns this. Complex numbers are generally used in fields like computer graphics. So for someone learning Python for web development or data science, they may not need to use them. In this part of the lesson, we will explore different operations that can be performed on the number data type. This involves using operators with numbers. Addition of numbers is done with the plus operator. The numbers on either side of the operator are called operands. Let's declare a variable summation equals 5 plus 5. Point summation. Let's run the program. In this case, we are adding two integers together. 5 is an integer because it is a whole number. Instead of using values directly, we can also make use of variables. Let's see that in action. A equals to 5 b equals to 10. Summation equals a plus b. Point summation. Let's run the program. In this case, instead of mentioning the value directly, we are referencing the variables we have already declared. We have already declared a and b. It is important to note that adding integers together will always result in an int, that is an integer. In this example, 5 is an integer, as well as 10. The result, which is the summation, will always be an integer. Let's check the type of summation. Print type summation. This shows that the summation is an integer. Whenever you add an integer to a float, the final result will be a float. In this case, variable a is an integer. Let's change variable b to be a float. 10.5. Let's run the program again and see the result. As you can see, the final result we have now is a float. We can use the minus operator to subtract two numbers. Let's declare the third variable. Difference equals a minus b. Point difference. Let's run the program. This returns the difference between a and b. Also note that subtraction between integers will always result to an integer. For float and integer, the result will always be a float. Let's change the variable a to a float. Point type. Let's run the program again. The final result is a float. To multiply two or more numbers, we make use of the asterisk sign. Variable c equals a times b. Point c. Let's run the program. This returns the multiplication of the two numbers. The forward slash operator is used to divide left-hand operand by right-hand operand. Division with the forward slash operator always returns a float, irrespective of the operands. Let's see that in action by running this program. Great. Python throws an error when you try to divide a number by 0. Let's change the variable b to 0. Python raises a 0 division error because you can't divide a number by 0. To raise a number to the power of another number, we use the double asterisk operator. Point exp. This is the same thing as writing 5 times 5 times 5. Let's execute the program. We are also allowed to raise number to decimals. This should return a float. Great. The modulus uses the percent sign and it returns the remainder of dividing the left-hand operand by the right-hand operand. One of the uses of the modulus is to determine if a number is divisible by another number. It returns 0 when the first number is divisible by the second number. Let's execute the program. This returns 0 because the remainder of dividing 6 by 2 is 0. Let's change 6 to 5. This returns 1 because the remainder of dividing 5 by 2 is 1. An expression is a combination of operands and operators that Python can compute to return a value. Understanding the order of precedence is crucial when dealing with expressions containing multiple operators to obtain accurate results. Operators with higher precedence are evaluated first before operators with lower precedence. In this example, 3 times 2 will be the first part to be evaluated before the other parts. 3 times 2 equals 6. 6 minus 1 equals 5. The expected result of this expression is 5. Let's run the program. Great. We can use parentheses to change the order of evaluation. Parentheses come before any other operator in the order of precedence. This means 2 minus 1 will be first evaluated before the multiplication operation. Let's execute the program. The result is different from the first expression because operation in the parentheses is evaluated first. Thank you for watching and I hope you enjoyed the video. See you in the next lesson.